Gravitational lensing is a fascinating phenomenon in astrophysics that occurs due to the bending of light by the gravitational force of massive objects. It was first proposed by Albert Einstein as a consequence of his general theory of relativity, which describes how gravity affects the curvature of spacetime. In simple terms, gravitational lensing refers to the deflection of light rays as they pass near massive objects such as galaxies, galaxy clusters, or even massive black holes. To understand gravitational lensing in full detail, let's break it down into several key aspects. 1. The nature of light. Light is composed of photons, which are massless particles that travel at the speed of light. According to Einstein's theory of relativity, photons follow the curvature of spacetime. This means that when light travels near a massive object, its path will be curved due to the bending of spacetime caused by the mass of the object. 2. Gravitational potential. Every massive object in the universe has a gravitational field around it, which creates a gravitational potential. The gravitational potential determines how light and other objects will move in the vicinity of the massive body. The greater the mass of the object, the stronger its gravitational field and the larger its potential. 3. Deflection of light. When a light ray passes near a massive object, it enters the region of the object's gravitational potential. As it moves through this potential, its path gets curved. If the light ray's trajectory takes it close enough to the massive object, the light will be significantly deflected from its original path. This deflection can be observed as a deviation in the apparent position of the light source. 4. Strong and weak lensing. Gravitational lensing can be categorized into two main types: strong lensing and weak lensing. Strong lensing occurs when the deflection of light is significant enough to produce multiple distinct and magnified images of the same background object. These multiple images form an Einstein ring or other more complex lensed configurations. Strong lensing is typically observed around galaxy clusters or massive galaxies. Weak lensing. In cases of weak lensing, the deflection of light is subtle and not enough to create multiple images of the same background source. Instead, it causes a slight distortion or elongation of the background objects, such as galaxies, on the sky. Weak lensing is widespread and occurs on larger scales involving larger regions of the sky. 5. Einstein's cross and other examples. One famous example of strong gravitational lensing is the Einstein's cross, where a distant quasar is lensed by a foreground galaxy, creating four images of the quasar around the galaxy. Other examples include galaxy-galaxy lensing and cluster lensing, where entire galaxy clusters act as lenses, magnifying and distorting the light of background galaxies. Gravitational lensing has become an essential tool for astronomers and cosmologists as it allows them to study distant and faint objects that would otherwise be difficult or impossible to observe directly. It also provides valuable insights into the distribution of dark matter in the universe and helps test the predictions of Einstein's theory of general relativity on cosmic scales.